Hello and welcome to the Idaho Reports podcast. I'm Logan Finney. Joining me this week is Daniel Strawn, who is a professor of environmental soil chemistry at the University of Idaho, to discuss some research that he worked on regarding phosphorus absorption in nutrient-enhanced biochar. Professor Strawn, thanks for joining us.
Hi, thank you for having me.
So nutrient-enhanced biochar sounds very sciencey and technical, so you're the one who did the research here and I'm not. Can you give us a layman's understanding of what the science is here and what research you were part of?
Sure. So this research project is this one paper that just came out. It's a product of a collaborative effort between several investigators. Myself and another PI, Greg Moeller, have been working on using biochar to recover phosphorus and nitrogen, which are major plant nutrients, and recover it from wastewater and reuse it in agriculture as plant nutrients. And so we developed a technology of using this biochar. So let me explain real quick what biochar is. Biochar is essentially in a very layman's term, it's just like the charcoal you use in your barbecue. And now there are differences, but it's very similar. So this biochar is produced from waste biomass, another probably technical term, but you can think of waste biomass as agricultural residue. For example, when you harvest wheat, that we only use the grain and the stalks and everything else are left over. Well, you can pyrolyze that and create this charcoal, what we call biochar. It's also produced from forest biomass.
And biomass is something that folks might be familiar with in the clean energy space, right? It's meant to be sort of an energy production that's not relying on fossil fuels.
Right. So yeah, that's a good point. So take for example, a lot of the biochar we're using now, what we call the feedstock or the main ingredient is actually forest biomass. So that perhaps a beetle kill or where a forest fire went through and there's a lot of trees that have died, they'll harvest those, and that's what we call biomass. And then so you can use that to produce energy actually in the pyrolysis, which is essentially heating up that biomass in the absence of oxygen, and it'll produce a biofuel. And so that's what you're referring to. And then as a byproduct of that biofuel production is the biochar or charcoal. And so we're taking that biochar and we found that it's very reactive. It'll sequester, absorb chemicals from solutions. And so we developed a process that we can use this biochar to treat wastewater, such as municipal wastewater, agricultural drainage, food processing water, or for example, right now we have a pilot trial going on at a dairy to treat that wastewater, dairy wastewater. And what we're trying to do is use this biochar and if we can, wastewater has a lot of nutrients in it, phosphorus and nitrogen. That's what causes algae growth in streams and lakes. And so we want to take that out, that phosphorus and nitrogen, which is a fertilizer, and we put it on the biochar, and then we take the biochar and we can use it to grow more plants. And so it kind of replaces the traditional fertilizers that farmers would be purchasing. And so it's really what I like, the big picture here is recycling. We're using biochar to recycle nutrients out of wastewater and instead of them going off into surface waters or just being discarded, we actually can reuse them. So that's the big picture of what we're doing.
Yeah, it seemed to me like there's kind of two ends of this process. There's using the biochar almost like a sponge to soak up the minerals where they would be discarded, and then you can actually use that in fertilizer. Is that the right understanding?
Exactly. Yes. Perfect. So, and it's really what's really neat about it is a lot of in the agriculture and in soil science, there's a lot of people really interested in adding biochar to soils because it improves soil health. Um, and what we're suggesting is that, okay, we can do that. Adding biochar to soil can be good, but why not add some of these recycled nutrients at the same time and offset the fertilizers that you traditionally have to buy? And so, a major, in addition to increasing soil health, it also sequesters carbon. So, biochar, when you add it into soil, it can last for 100 to 1,000 years. So that carbon is essentially in that soil, and it reduces the overall carbon loading to the atmosphere or offsets it, I should say, by adding the carbon to the soil.
And in terms of soaking up these or capturing these minerals like phosphorus and nitrogen in wastewater plants, that has environmental benefits as well, too, doesn't it? Like personally, I've done some reporting and coverage of in the Lake Coeur d'Alene Basin. They're working very, very hard, and the state has invested a lot of money in preventing phosphorus loading into the lake for some environmental concerns from historical mining up there. And of course, phosphorus causes algae blooms all over the country. So is this
Yeah,
also an environmental technology possibly?
yes, exactly. I think what was really neat about this project is we really tick off a lot of boxes. I mean, we're capturing carbon, we're recycling nutrients, and we're cleaning water. With the technology, we incorporated biochar in a water treatment technology, that technology, and we actually have a patent for that. Um, and we can, with this technology, we can essentially reduce phosphorus down to, I mean, below detection level. And so that's great because otherwise a lot of wastewater plants and agriculture industries, they are emitting phosphorus and nitrogen into surface and groundwaters. And like you said, it creates a big problem in promoting algae growth, and may have heard of things like harmful algae blooms, HABs. And so all that's bad, and it's in freshwaters and estuaries, in the big anoxic zone in the Gulf of Mexico. It's all caused by excess nutrient loading. And so this technology has the potential to be part of the solution for capturing those nutrients and keeping them out of the water.
And so, like you referenced, the University of Idaho now holds a patent for this biochar water treatment process that you worked on. You also worked with researchers from Washington State University and the University of Saskatchewan, is that right?
Yeah, that's correct. Manuel Garcia Perez and Derek Peak are professors at those universities, and they were instrumental in moving this project forward. Like all research is usually done by a collaboration. So it was really good to work with them. Manuel Garcia Perez is a professor at Washington State University. He is an expert on biochar production. And so he had some really interesting biochars that we did research on and report on in this paper. And Dr. Peak, Derek Peak, he's at University of Saskatchewan, and he's an expert on phosphorus chemistry. Has similar skill set as I do, but he's at the University of Saskatchewan. It's right next to the Canadian Light Source, which is a giant synchrotron up in Canada. So he really is an expert at using that facility, and we collaborated and worked together to collect some really unique data to help us understand how this biochar can be used in water treatment.
Yeah, tell us a little bit more about the Canadian Light Source, that giant synchrotron. Tell us,
Yeah,
not too technical, but
yeah,
tell me, what is this facility and what did it specifically allow you to look at here?
sure. Right. So a synchrotron is essentially, imagine something of a big circle the size of perhaps a football field, diameter of a football field. And it's got a ring on the outside, and essentially photons and go around this ring, and as they're bent around the ring, they emit X-rays. And so an X-ray is essentially what we call the light source. And so these synchrotrons can produce really bright X-rays. I mean, I can't remember off the top of my head, but on the order of 100,000 to 1,000,000 times brighter than the X-ray that you go to the doctor to get X-rays with. So they're really bright, and so we put this biochar in front of those X-rays, and it gives us some information about what the biochar and the phosphorus, how they're interacting. And so it's a very advanced technique. These facilities are, hundreds of millions of dollars to build and operate. And so they're really, they're very powerful, and it's really a great opportunity to work at them. It's very competitive to get time at them. So we were very fortunate because there's a lot of scientists that want to access them, so they have to limit the availability. And so we were really fortunate to be able to use the Canadian Light Source